Welcome to week 9, chapter 8. Can you believe we're more than halfway through our course? So this week we're going to take a look at prescriptive analytics, optimization, and simulation. So that's what we're going to be looking at. Understanding the applications, prescriptive analytics, techniques, and a combination of reporting, understand the basic concepts of analytic decision making, describe how spreadsheets work, help us with the modeling. So these are some of the things that we're going to be looking at. Let's take a look at our vignette. School district in Philadelphia uses prescriptive analytics to find the optimal solution for awarding bus route contracts. So busing is a huge thing. Background: selecting the best vendors to work with, laborious yet important task for companies and government organizations. After the vendor submits proposals for specific tasks through the bidding process, the company and organization evaluates that and makes sure. The District of Philadelphia uses bidding process to select one or more vendors. In this case, we're looking at the private bus route. It owned a few buses but needed more to serve the student population. They wanted to use their own school buses for 30 to 40% of the route and outsource the rest. Historically, the process is deciding which bus vendor contracts are awarded given the budget and time restraints was laborious as it was manually by hand. Vendors were evaluated based on 5 things: cost, capabilities, reliance, financial stability, and business acumen. Each vendor submitted their proposal and they looked at it. Initial look for software that was used in conjunction with his contract model in Excel. He began using the Premium Solver platform from Frontline Systems, which allowed them to most beneficial vendor for the district from a financial and operational standpoint. He created an optimization model that took into account the aforementioned variables that we looked at. This amounted to about 1,600 variables. In addition to some of the benefits, in addition to determining how many of the vendors should be awarded the contract, this helped develop the size of each contract. The size of the contracts varied, one vendor getting 4 routes, another receiving 97 routes. Ultimately, the school district of Philadelphia was able to create a plan and optimize the number of bus companies using Excel instead of manually handwritten. This is where we're able to take a look at some of the different areas and figure out how we're going to do it. Excel is a very powerful tool. I know we've looked at it in the past. Modeling-based decision-making, prescriptive analytics, models, examples, identification of problems, and environmental analysis, and model categories. We're going to take a look at this. As the vignette indicated, making decisions using some kind of analytic model is what we call prescriptive analytics. In the last chapter, we learned the value of the process of knowing the history of what's going on and used might entail. So let's take a look. Hang on here. Methodology. Let's see. No, that's not what I want. Prescriptive analytics. Modeling is the key element for prescriptive analytics and the examples mentioned earlier. Sorry about that. Modeling, prescriptive analytics. Modeling is the key element for prescriptive analytics. In this example, deciding which customer to recommend a decision for a realistic problem, deciding who will receive the offer, building probabilities based depending on the problem that we're addressing. There's different modelings that we can look at as we take a look at some of the different ones. Identification of the problem environment. No decision is ever made in a vacuum. It's important to analyze the scope of the domain and the forces and dynamics of the environment. The decision maker needs to identify the organization's culture, the corporate decision making. It's entirely possible that the environmental factors have created the current problem, which is the monitoring. Business intelligence, business analytic tools can help identify problems for scanning from. The problem must be understood and everyone involved must take a look at it. Identification of the models variables, is critical as the relationship among the variables influence diagrams, which are graphical models, mathematical models that we can use. Forecasting. As we noted, important prerequisite of prescriptive analytics, knowing what has happened and what is likely to happen. This is a form of predictive analytics and essential for construction and manipulation models, because when the decision is implemented, the results usually occur in the future. There's no point in running a what if the analysis of the past, because the decisions made have no impact on the future. Online commerce and communication has created an immense need for forecasting and abundance of available information for programming it. Activities quickly allow us to have this. Models categories. Classifies some decision models into 7 groups and listed in several representatives, as you can see on the screen. Each technique can be applied to another static or dynamic model, which can be constructed under assumed environments of certain uncertainty or risk. To expedite the construction, we can use special decision analysis systems that have modeling this OLAP. So if we look at it, category optimize with problems with few alternatives, find the best solution for small number of alternatives, and decision tables and trees. Optimize via algorithms, find the best solution from a large number of alternatives using step-by-step processes. Linear and mathematical programs, optimization via the analytical formula, find the best solution. We have some inventory models. Stimulation, find a good enough solution. Heuristic, find a good enough solution using rules. Predictive, predict the future for a given scenario, forecasting models, and others. Model management. Models like data must be managed to maintain their integrity, and thus such management is done through the aid of a database system. Knowledge-based modeling, DSS, uses mostly quantitative models, whereas expert systems use qualitative knowledge-based systems. Current trends in modeling. One of the recent model trends, develop model libraries and solutions. Structure of mathematical models for decision support. All quantitative models are typically made of 4 basic components. Decision variables, uncontrollable variables, intermediate variables, all go into a mathematical relationship and we get our results. The results variable reflects the level of effectiveness of the system. That is to indicate what's going on. Intermediate results variables are sometimes used in the modeling. area, financial, we'll use investment, alternative amount, result variables, total profit, rate on return, earnings per share, net, uncontrollable, inflation rate, prime rate, competition. Marketing, advertising budget, where to advertise, what's our market share, customer satisfaction, customer income, competitors' action. Manufacturing, decision variable, what and how much to produce, inventory level, compensation. The result variable, total cost, quality levels, employee satisfaction, non-controllable, machine capacity, technology. And we can look at accounting, use of computers, audit schedule, data processing, error rate, transportation, shipment and schedules, use smart cards, total transportation costs, delivery distance, services. So as we look at the different areas, decision variables describe alternative course of action. The decision maker controls the decision variables. For example, investment problems, the amount to invest in bonds, and the decision variables, and this uncontrollable variables and parameters. In any decision-making situation, there are factors that affect the result variables but are not under the control of decision-making. Either of these factors can be fixed, in which case they are called uncontrollable or parameters. Variables. Example of a factor, prime rate. We can't control it. Intermediate result variables. Intermediate result variables, outcomes in mathematical models, determine the machine scheduling, spoilage, and intermediate variables, and total profit. Certainty, uncertainty, and risk. Decision modeling process involves evaluating and comparing alternatives. During this process, it is necessary to predict the future outcomes of each proposed alternative. Decision situations are often classified on the basis of what the decision maker knows or believes about the forecast results, what we customarily classify as knowledge. Certainty, uncertainty, and risk. Increased knowledge. We got that one, I'm sorry. Complete knowledge, certainty, total ignorance. As we look at if we have complete knowledge, we can increase our knowledge. So let's take a look. When we develop models, any of these conditions can occur in different kinds of models. Decision-making uncertainty. In the decision-making under certainty, it assumes that the complete knowledge is available so that the decision maker knows exactly what the outcome of each course of action will be. It may not be true that the outcome decision maker on uncertainty is decision maker considers a situation in which several outcomes are possible for each course of action. In contrast to a risk situation, in this case, the decision maker does not know or cannot estimate the probability of possible outcomes. Decision making under uncertainty is more difficult than decision making in certain because of this. A decision made under risk is one which the decision maker must consider several possibilities that the outcome will occur and assumed to be known or can be estimated. Under these assumptions, the decision maker can assess the degree of risk associated with each alternative. Risk analysis is a decision-making method that analyzes the risk associated with different alternatives. Risk analysis can be performed by calculating what we're trying to do. Decision-making models. We'll look at what if, goal seek, data management, and programmability. Models can be developed and implemented in a variety of programming languages and systems. We focus primarily on spreadsheets, modeling languages, and transparent data analysis tools, where their strength and flexibility. Spreadsheet packages are quickly recognized and easy to implement software for development wide range of applications. Spreadsheet packages involved add-ins where development and structure and solving specific model cases. Among these, we're able to have add-ins. Spreadsheets are clearly the most popular end-user modeling tool because it incorporates the most powerful financial, statistical, mathematical, and other functions. Spreadsheets can perform modeling solutions, linear programming, and regression. The spreadsheet has evolved into an important tool for planning and modeling. Most spreadsheet packages provide fairly seamless integration because they read and write common file structures and are easy to interface with databases and other tools. Microsoft Excel is one of the most powerful spreadsheets. We've shown some loan calculators along with some other things. Static and dynamic models can be built in a spreadsheet. For example, a monthly loan calculation is shown. Without a problem affects the borrower over time, the model indicates a single month performance which is repeatable. Mathematical programming optimization. Mathematical programming is a family of tools designed to help solve managerial problems in which the decision maker must allocate scarce resources among competing activities to optimize measurable goals. For example, the distribution of a machine time among various products, typical allocation problem, linear programming, is best known technique in the family of optimization tools called mathematical programming. Relationships among the variables are linear. It is used extensively in the DSS model. Every linear program model is composed of a decision variable. An object function. Object function coefficients, constraints, capacities are what we're looking at. Multi-goal sensitivity analysis, what-if analysis, and goal-seek. Many, if not most, situations involve juggling between competing goals and alternatives. In addition, there's a significant uncertainty about the assumption and the predictions being used in the building prescriptive. Multiple goals. The analysis management decision aims at evaluating to the greatest possible extent how far each alternative advances managers towards their goal. Unfortunately, managerial problems are seldom evaluated with the single simple goal, such as profit maximization. Today's management systems are more complex than with a single goal is rare. Instead, managers must attain it. Simultaneous goals, and some of them conflict. Different stakeholders have different goals. For an example, consider a profit-making firm. In addition to earning money, the company wants to grow, develop its products and employees, provide job security to its workers, and serve the community. Managers want to satisfy the stakeholders and at the same time enjoy high salaries. Sensitivity analysis. A model builder makes predictions and assumptions regarding input data, many of which deal with the assessment of uncertainty futures. When the model is solved, the result depends on these data. Sensitivity analysis attempts to assess the impact of change and the input proposed solution. Sensitivity analysis is extremely important in prescriptive analytics because it allows flexibility, adaptation to changing conditions, and the requirement of different decision makings, provide better understanding of the model decision making. The impact of change is external variables and impact. The impact of change in decision making variables on outcome. The effect of uncertain estimated externals, the effect of different dependent revising models. Sensitivity are also used for revising models, elements too large sensitivities. Automated sensitivity analysis. Automated sensitivity analysis is performed in the standard quantitative model implementation, such as linear programming. It reports the range within which a certain input variable parameter, trial and error sensitivity, the important in any variable or several variables can be determined through a simple trial. What if analysis? What will happen to the solution if the input variable or assumption or parameter values change? What will happen if the total inventory cost carrying inventory increases by 10%? What will the market share if advertising budgets by 5%? With appropriate user interface, it is easy for managers to ask computer models these types of questions and get immediate answers. Furthermore, they can perform multiple cases and thereby change the percentage of any other of the data questions. Goal seek. Goal seek calculates the value of input necessary to achieve the desired level of an output. It represents backward solution programming. What annual R&D budget is needed to annual growth of 15%? How many nurses are needed to reduce the average waiting time in patients? An example of goal seek is financial planning in Excel. The rate of return interest produces net present value of 0, given the stream it is likely to have. Decision analysis with decision tables and decision trees. Decision situations that involve the finite and usually not too large number of alternatives models through the approach. It's called decision analysis. Decision tables conveniently organize information and knowledge in a systematic tabular manner to prepare it for analysis. For example, say that an investment company is considering investing in one of 3 alternatives: bond, stock, certificates. The company is interested in one goal: maximizing the yield of that. The yield depends on one of the things. The problem is that we have this. Investment decision problems can be viewed in 2 ways. Payoff mathematically and what we have. So if we have alternatives: bonds, stocks, or CDs. Solid growth, 12, 15, and 6.5%. Stagnation and inflation. What will it have an effect on it? Treating uncertainty. Several methods available for handling uncertainty. For example, the optimistic approach assumes that the best possible outcome of each alternative will occur and then selects that. Treating risk. The most common method for solving this risk analysis problem is to select the alternative with the greatest expected value. Assume the experts have what we need. Decision trees. An alternative representative of the decision table is a tree. It shows the relationship of the problem graphically and can be handled complex situations in compact form. However, decision tree can be cumbersome if there are many alternatives and states. Introduction to simulation. Very broadly, these methods fall under the umbrella of simulation. Simulation appears of reality. A decision system simulation is a technique for conducting experiments with computer on model of management system. Simulation is a descriptive rather than prescriptive method. There's no automatic search for an optimal solution. Instead, the simulation model describes or predicts the character of the given system under different conditions. When the values of the characteristics are computed, the best of the several alternatives can be selected. The simulation process usually repeats an experiment many times to obtain an estimate of variance overall. Typically, the real decision situation involves some randomness because many decision situations with semi-structured or unstructured situation, reality is complex, which may not be easy to represent the optimum. Some major characteristics. Simulation typically involves building a model of reality, and to the extent of practical simulation models may suffer from fewer assumptions about the decision situation as compared to other prescriptive tools, but has what we need. Advantages of simulation. The theory is straightforward. A great amount of time compression can be attained. Simulation is descriptive rather than normative. A manager can experiment with determine which variables are most accurate. An accurate simulation model requires an intimate knowledge of the problem. The model is built from the manager's perspective. Simulation can handle extreme things. Some disadvantages. An optimum solution cannot be guaranteed. Simulation model construction can be slow and costly. Solutions and inferences from the simulation study are not transferable. Simulation is sometimes so easy to explain that managers that it's hard to overlook, and simulation software sometimes requires special skills. The methodology of this: define the problem, construct the simulation model, test the validity of the model, and design the experiment. Conduct the experiment, evaluate the results, implement results. That is what our diagram shows. Focus more on the model than the problem, provide point of estimates, not knowing when to look. Visual interactive simulation. We next examine the method, conventional simulation inadequacies. Simulation is well-established, useful, descriptive, mathematics-based method for gaining insight into complex decision-making situations. However, simulation does not usually allow decision makers to see how the solution is complex to the problem. Visually interactive problem solving is a simulation method that lets decision makers see what model is doing and how it interacts with decisions that are made. This technique has been used with great success in operations analysis in many fields such as supply chain and healthcare. The user can employ his or her knowledge to determine and try different decision strategies while interacting with the model, enhance learning about the problem and the impact it has. Visual simulation uses automated computer graphics to present the impact in different managerial decisions. It differs from regular graphics in that the user can adjust the decision-making process. A visual model of the graphics are used. Visual interactive models in the decision support system consist of priming, usually interacting models. Waiting line management or queuing is a good example. Some highlights. Models play a major role in the decision support system. Models can be static. Analysis conducted under assumed certainty. Influence diagrams graphically. Spreadsheets have many capabilities. Simulation can deal with this, and we have the visual. So for week 9, your assignment, Chapter 8, discussion questions 1 through 4, and exercise 4. Remember, that's an APA, complete sentences, and your discussion question. Thank you.